Welcome back. We're going to go through measuring and classifying different types of angles. So first we need to discuss what the definition of an angle is, and it consists of two different rays with the same endpoint. So in this picture down below, one ray is AC, the other one is AB, and there are two of them. So those make up the sides of the angle. The point where it joins together is called the vertex, and that's where the endpoints are. So the two names of our angle, so the two sides, of the names of our angle is ray AC and ray AB. And remember to pay close attention to the notation of how we write those. So you write it as a ray, and if you read this, it starts at point A and then keeps on going through point B. It starts at point A and then keeps on going through point C. So point A and point A are both the endpoints. And there are two names that we can name this angle, or really three names. We have to use three letters, and the middle letter needs to be the vertex angle. So we can start at C and then go to A and then B, or we could start at B, go to A and then C, or because there is only one angle here at letter A, we could just say it's angle A. So notice that we put this little angle symbol right before our angle. So it says that we're talking about angle CAB and angle BAC and angle A. And if you see in our picture up above, point A is the vertex of our angle. So it doesn't say on here, but I would like you to try this on your own since we already went through the first one and labeled different ways of labeling an angle. So on this one, I would like you to go through and come up with three angles that are in this diagram. So there's really two smaller ones and one large one, just as a hint. So push pause, work out your answer, and then go ahead, push play, and check your answer. Alright, so now that you're ready to check your answer, here is one name, and one name could be our WXY. Now remember, we switched the letters around, so that's why I wrote it as YXW for the other alternative. So that we can do the same thing for this bottom angle right here, so YXZ or ZXY. The third angle would be the whole angle, so WXZ or ZXW. Now, what would be the incorrect response if I just wrote angle X? Why would that not work? So as you're thinking of that, remember that if we only use one letter to label it, that means that there's only one angle that could have angle X as a vertex of the angle. So if you're looking over here on the right hand side, there are three different angles that have angle X as the central vertex. So that's why angle X, we cannot use angle X as our way of describing that angle, so we have to use at least three letters. We will be using a protractor to measure some different angles, or you might see a picture of a protractor with some angles on top of it. So a protractor can be used to measure angles, and an angle is measured in degrees. And just like with segments, we have to be careful if we mean the distance from point A to point B versus segment AB. We write those two different ways. We have to be careful of the same thing when we are talking about angles. So there are two ways of writing an angle. So we can say literally the measure of the angle is 32 degrees, or we could put this little m ahead of it, and that means that the measure of angle, so our angle symbol, so measure of angle WXZ equals 32 degrees. So next, for classifying angles, there are four different ways to classify an angle. So there's an acute angle, so that's when the angle degree is between 0 and 90. No angle can equal exactly 0 degrees or it won't create an angle. And if it's 90 degrees, then that means it's a right angle. So if it's right angle, it's equal to exactly 90 degrees. If it's above 90 degrees, but it can't be past 180 because 180 degrees is a straight angle, so that's why it's between 90 and 180 degrees is an obtuse angle. And a straight angle means exactly what it shows, a straight line, and if you look at protractor, that goes all the way and it's 180 degrees. So there's two of them, the right angle and a straight angle, that we're going to be creating our note cards with our if-then statements on it tomorrow in class. Alright, so this is just to practice writing and finding the measure of an angle looking at our protractor. So I'm going to do the first two with you, and then you can do C and D by yourself. So our angle KHJ, we want to look at our picture on the side. So KHJ, and it goes in order. So if you notice, KHJ is this angle right here. So when you look at your protractor, there's two different locations that that angle is crossing it. Now think of, is it an acute angle or is it obtuse? So is this angle bigger than 90 degrees or is it less than 90 degrees? And this one is less than 90 degrees, so it's an acute angle. Acute, because it's less than 90. So when we're looking at our two different variations, we could have a 55 degrees or 125 degrees. 125 degrees would actually be an obtuse angle, so we want to use our 55 degrees. So next, for this second angle, GHK, so GHK is this whole angle, so it is from here to here, or you could go the other direction, it really doesn't matter where you start. So that's an obtuse angle because it is larger than 90 degrees. So when I'm looking at those same measurements over there, I have a 125 degrees or I have a 55 degrees. So I want to use the 125 degrees for GHK. Alright, so now I would like you to push play and answer letter C and D, and then check your answer when you are ready. Alright, so we already said that letter A was 55 degrees for that angle. Letter B was 125, so that was an acute and an obtuse angle. Your letter C ends up being a straight angle, so 180 degrees. And letter D is our right angle, so it came out right at 90 degrees. Alright, so these are both questions that you will try on your own. So just combining the last couple of days or videos. So talking about opposite rays, right angles, naming our angles using our 3 letters, and then also describing what type of angle we have. So go ahead and push pause, work out your solution, and then when you're ready to check your answer, push play. Alright, so the 3 different angles that are in this picture are PQR, RQS, and PQS. Now realize your letters could be backwards. You could have RQP, SQR, and instead of PQS you could have SQP instead. And the angle that forms a right angle is our PQS or SQP. So with the next question, when we draw a pair of opposite rays, this is what your picture should look like. And the opposite rays I have in my picture is MN and ray MO. When we have to label what type of angle it forms, that this is obviously a straight angle, so our angle NMO or OMN is a straight angle, which remember is 180 degrees. Alright, so just like the segment addition postulate, we have an angle addition postulate, and it works the same way. So if we have the point P is between our angle RST, then that means that there's basically a ray that goes down through the angle. We don't know exactly where it is, but we do know that if we add the 2 pieces of our angle together, that it should equal the whole thing. So angle RSP plus PST should equal RST. So the measure of each of those angles, and that's what is written right here. And we're going to use this statement tomorrow in class to fill out another one of our cards for our little binder. So using that idea, we can set up our general equation for the angle addition postulate for this diagram right here, and then use that to find the measures of our angles. So since we know that M is now between L, K, and N in our angle, we know that if we add the measure of LKM plus the measure of angle MKN together, that it should equal the measure of angle LKN. And then with this information, we can combine the different pieces and put it into this equation. And one of the pieces of information in the original problem, it said that LKN, so that's the whole angle of everything, is equal to 145 degrees. So when I add the 2 pieces together, it should equal this 145 degrees. So now we have this equation, and you can see where the colors came from in our equation, in our picture, and we can solve now for x. So go ahead, push pause, work it out yourself, solve for x, and then remember we need to substitute it back in so that we can find what these 2 values are of the measures of those angles. So go ahead, push pause, and when you're ready to check your answer, you may push play. Alright, so when you have solved for x, you should have gotten a 23 for the x. For the 2 different degrees of your angles should be a 56 for the first one and an 89 degrees for a second one. And this is what your work will look like. All right, so these are two questions that you will be doing on your own. So one thing you need to take note of is the fact that this one, first one says that it creates a straight angle, the second one creates a right angle. So if you need to, you can rewind back to the degrees of a straight angle and the degrees of a right angle so you know what your equation will equal in the end, but you need to use the segment, or the angle addition postulate to set this up. So you're going to be adding some different angle pieces together to equal the degrees of a straight angle. You're going to add some pieces together in our equation to equal the degrees of a right angle. So go ahead and push pause and work out your question all the way. You can do each one individually if you would like to, and then go back and check your answer when you push play. All right, so the first one you should have added the 10x minus 5 plus the 4x plus 3 equal to 180 degrees, and you get x equals 13. Then because x equals 13, you need to substitute it back into angle KLN and angle NLM to find the individual measurements. So the first angle in red will equal a 125 degrees. The second one in blue equals a 55 degrees. And if you look up at our picture, that does make sense. The reasonableness is there because if you look at this first angle, this is an obtuse angle, and 125 degrees does create an obtuse angle. And this blue angle, the second one, is acute, and our 55 degrees is acute. Not all the time will the picture match what our answer comes out as, but at least we can check our answer that way. All right, so your second problem over here should equal 90 degrees in the end. When you solve for the x after you set up your equation, you should get x equals 29. Again, when we substitute the 29 back in to both of the responses, that didn't come out very nicely, that we end up with 60 degrees for this first angle and a 30 degrees for the second one. This section is also similar to what we saw before with segments, that if we have congruent angles, that means that we have two angles that have the same measure. And we are going to take this box here in the center, and we're going to use this first one, how equal measures implies congruence, and congruence implies equal measures. So we can go back and forth to that. Those will be two separate cards when we get back to class that we're going to fill out. So using this idea that our two congruent angles, that they have the same measure in this picture down below, that we're going to first go through, and I want you to draw your picture, and then label the three angles that are given in your picture. So in our picture, you can see that this 121 is also for our angle T. The 130 does not match up with anything else, but this 84 will also be congruent to this angle P. So the two missing angles that we have is our QPT and PTS are the two angles that we're missing, and now we know what they are. The first one is 84 degrees, second one is 121 degrees. So an angle bisector is very similar to a segment bisector, and we have a ray that divides an angle into two angles that are congruent. And we will also fill out one of our note cards for this definition. So if we know that the YW in our picture over here on the right, if ray YW bisects angle XYZ, then we know that XYW is congruent to angle WYZ. So in our problem in this one, we know that since YW, the ray YW, bisects this full angle, and it tells us that angle XYW, so this first part is 18 degrees, then we need to find out what the angle XYZ is equal to. Well, if this first one is 18 degrees, and we know that the second one is congruent to it, then we know that that one is also 18 degrees because they are congruent, or they're equal in measure. So if both of them are 18, then technically we could just add 18 and 18 together, or you could double 18 to find out what the angle is of XYZ. So what I've already written is that we know that the two individual angles that are congruent, and because they're congruent, we know that they're equal measure, so that means that this other angle is also 18 degrees. So if we need to find the angle XYZ, we could do two different things. I'm going to just add 18 and 18 together, and that should equal our whole angle. All right, here's a challenge question that I would like you to try to draw before you come to class tomorrow. So you have an angle that's a straight angle, and you also have NQ, so notice that point N is the same, so they share that point. So the ray NQ bisects the angle MNP. And I want you to draw the angle NMP and the ray NQ that goes through it. And because it bisects it, and you know that it was originally a straight angle, I want you to first mark the arcs that show that they're congruent to each other. You saw that on some of the other diagrams. And then I also want you to figure out what the individual angles are going to be based on your figure and what you know about it. See you tomorrow.